Let's examine how we can convert recursive and explicit forms of arithmetic sequences. We're going to look at how we can convert from recursive to the explicit form and then also from the explicit back to the recursive form. Let's start with converting from recursive to explicit. When you have the recursive formula, the first thing you want to do is generate a sequence of about 4 to 6 terms. Doesn't have to be 4, it doesn't have to be 6. You can stop at 4, you can stop at 3. But one thing you want to do is just generate a sequence to establish a number pattern. You identify the first term, identify the difference between each successive term, and then you're going to write the formula in the form f of n equal to a plus n minus 1 multiplied by d. Let's put that to practice. So let's go ahead and identify a sequence. So our sequence is going to start with f of 1 is 7. Then the second term is going to be f of 1 minus 4. 7 minus 4 is 3. The third term is going to be f of 2 minus 4. So 3 minus 4 is negative 1. And then your fourth term is f of 3 minus 4, which is minus 1 minus 4, which is going to give you minus 5. And then we continue till eternity or indefinitely. So let me just show you how I did this on this first example. So f of 1 is equal to 7. F of 2 is f of 1 minus 4. F of 3 is f of 2 minus 4. And then f of 4 is f of 3 minus 4. So what we see here is our first term is equal to 7. Our common difference, we can see that what we're doing every time is we're subtracting 4. So d equal to negative 4. So our explicit formula is going to be, the way we want to write the formula is a plus n minus 1 multiplied by d. So we have 7 plus n minus 1 multiplied by negative 4. So we have 7 minus 4 times n minus 1. That is our explicit formula. The next example, f of 1 is negative 5. F of 2 is negative 5 minus 4. F of 3 is negative 5 minus 4 minus 4. F of 4 is negative 5 minus 4 minus 4 minus 4. So here's what our sequence is going to look like. We have negative 5, and then we have negative 9, we have negative 13, and then negative 17, and we continue infinitely. And so our function is going to be f of n is equal to negative 5 plus n minus 1 multiplied by negative 4. So this is negative 5 minus 4 multiplied by n minus 1. So this is our explicit formula. Now let's go look at going from explicit to recursive. The one thing you can do is, there are going to be some similar steps. We will generate a sequence of 4 to 6 terms. Just use your discretion there. If you feel using 3 will be enough for you to establish your sequence, that's also fine. And then you want to identify a first term. You want to identify the difference, and then you want to write your formula in this format, the recursive format. Let's try a few examples here. So we have f of 1 is 12 minus 7, 1 minus 1, which is 12. F of 2 is 12 minus 7 times 1. F of 3 is 12 minus 7 times 2. f of 4 is 12 minus 7 times 3. So we have 12 here, we have 5 here, we have 12 minus 14, which is negative, and then here we have 12 minus 21, which is negative 9. So here's what we have for our sequence. We have 12, 5, negative 2, negative 9, and we continue infinitely. And so we're going to write our formula. F of n is going to be, draw our braces here. The first term is 12. This is when n equal to 1. And then we have f of n minus 1. And every time we are subtracting 7, because here our d is 7, which is our common difference. This is when n is greater than 1, so we subtract 7. So that is our recursive formula. Let's try a final example. F of 1 is negative 16. F of 2 is negative 16 plus 12 times 1. F of 3 is negative 16 plus 12 times 2. F of 4 is negative 16 plus 12 times 3. So we have negative 16 plus 12 is going to give us negative 4. Negative 16 plus 24 is going to give us 8. Negative 16 plus 36 is going to give us 20. So our sequence looks like this. Negative 16, negative 4, 8, 20, and we continue infinitely. So for our recursive formula, f of n is equal to, we're going to draw braces. We have negative 16, then we have f of n minus 1. We can see every time we're adding 12 to the previous term. So this is plus 12. This is when n equal to 1. This is when n is greater than 1. So these are the steps to follow when you want to go from recursive to arithmetic and also from arithmetic to recursive.